So we're going to continue talking about the quadratic formula and solving for x. But of course, some of the problems start to get a little more interesting as we go through them. So here we have, of course, an example where a is equal to 2, our b is negative 6, and our c value is, of course, 5. Remember, one of the techniques that we like using is finding the discriminant first. It will save me some time with some of the problems later on, but it's also going to tell me whether I'm going to have one real solution, two real solutions. And of course, we haven't seen this happen, but maybe we can have some imaginary solutions as well. So we're going to get our formula ready. Here we go. It says write the b value. Yes, you bring in the negative 6. The a value is 2. And our c value is 5. So we're going to work this out. And again, feel free to use Desmos to get this work going, this entire thing going for you. Negative 6 squared is positive 36. Any negative to a power 2 is always positive. And then negative 4 times 2 times 5 is negative 40. And so here you see we have our first example of where we're going to have a function that is officially two imaginary solutions. So we have two imaginary roots. Just shorter to say roots than it is to write out the word solution. So because of the negative, we have two imaginary roots that are going to come out of this. And that's fine. We're still going to approach the problem like we have for all the others. So it's not going to change any of those steps. So here we go. So now we're going to go with our actual quadratic formula. So let's remind you of what that is. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now remember, this wasn't a waste of time because now when I set this one up, yes, it's negative b plus or minus, here's my square root over 2 blank. All right, first things first, it says I need a b value, so that's negative 6. The discriminant, remember, you already worked the discriminant out. You already did the discriminant out here, and we got an answer of negative 4 for this whole thing. So inside, all I have to do is just write the negative 4 again by taking the discriminant or by working out the discriminant in advance. We avoided all this extra work in here. We've already done the work for ourselves. And then the a value was just a 2. So here's our 2. All right. So it says x is equal to negative times a negative is positive, plus or minus. Remember, when you take a square root of a negative 4, that means no real solution. But we already know about the complex number system. So when I see a negative inside, there comes the letter I for imaginary. And the square root of 4 is just a 2. Now we get to our denominator. 2 times 2 is just a 4. Now, this one does require a little more work. If you notice, every single number here can actually be reduced. So we're going to try to reduce those numbers now. But I can officially divide all three numbers by 2. And remember, we only take this step of reducing if I can reduce all three. If I can only reduce two of them, then maybe we don't want to mess with it. But here we can reduce every single one. So we end up with 3 plus or minus 2 divided by 2 is just 1i. 4 divided by 2 is 2. And then we can just separate now, the way we normally do for complex numbers. I'm just going to leave the plus or minus. Be careful here. There is an invisible 1, don't forget. So it's still 1 over 2, but with an I next to it. And so there's our answer for this one. So again, they can get a little more complicated, especially if we get a negative result, then we know we're going to have two imaginary values. Now let's look at number 6 here. For number 6, same situation. Here's our A, here's our B, here's our C. So let's get that practice in. Here comes our discriminant. I'm going to go right into it this time now. I just needed to remind you about it over here. Okay, so it says we need our B value, so that's 10. Our A value is 3, and our C value is negative 4. Again, we're just reviewing this concept of quadratic formulas a little bit more. So we end up with 100. Again, please let Desmos do all this work for you if you want. I don't have the Desmos open here, so we're going to work it all out by hand the way we used to do back in the day. So this is 48. Add it up, we have 148. Now, remember what this means, of course. This is a positive value. And because it's positive, we're going to have two real roots. two x-intercepts that are real for us here. Remember, that's what a root is. It's an x-intercept. It's a solution. It's a zero. We have two real zero values that are going to come out. And so now I'm going to take the time and take my my quadratic formula, which is negative blank for the b plus or minus the square root all over 2 blank. But remember, we're going to save a little bit of time because my discriminant, which I already worked out, is right here. We've already done the work for it. So I know the 148 will go in here. Now, my b value is a 10. My a value is a 3. Now, we do have to remember that when we have a square root, well, let me write my negative 10 first. And 2 times 3 is 6. Let's get the easy part out of the way. But here's what I wanted to mention. When you have a radical or a square root of 148, just like we do here, we have to ask ourselves, can this radical be simplified? Well, that's why we have our tree factorization that we've done before. So here's our 148. Let's see. 148, it's 2 times 74. And then, of course, if I have a 148, I'll break this down even further. I know 2 goes into the 74. But let's see, how many times does 2 go into 74? We're looking at a 37. But that's it. A 37 can't be broken up. So here are the leaves of the tree. And because we have a matching pair of 2's, we know a 2 is going to come out. But that radical 37 didn't have a matching pair. Let me show you here like this. This has a matching pair, so a 2 comes out, but that radical 37 remains. So this is what we write in here. Instead of square root of 148, then we say 2 times the radical 37. Okay, but look at what we have here. We have an outside value, a second outside value, a third outside value, and all of them can be reduced. You can try these out, and then we'll come back to the video so you can double check your answers. All right, well, let's see how you did here. Yes, we have an A value of 1, a B value of negative 8, and a C value of 5. All right, here we go with the discriminant. B squared minus 4AC. All right, negative 8 squared minus 4 times 1 times 5. Again, please let Desmos help you out with all of that. Makes it a lot easier. But we should have ended up with a 44. Yes, it's positive. So we're going to have two real solutions or roots or x-intercepts. Remember, they go by different names, even zeros as well. So we're going to end up with two real roots. All right. So now I'm going to take this information right here. We know this number is going to get used a little bit later here in our problem. All right. Let's go with the quadratic formula now. With our quadratic, we go x is equal to negative blank plus or minus a square root of all over 2 blank. Yes, make sure that fraction line stretches out. Don't forget. So here is our value that we are about to find. Our b value is negative 8. There it is. Our root was 44, so we're going to put a 44 in there. That's what we got for our discriminant. And of course, my a value is just a 1. So here we go. X is equal to positive 8 plus or minus. I'm going to take care of the bottom first. So that's just a 2. But now we have to talk about that square root of 44. So we're going to take a little moment down here at the bottom. Square root of 44. Let's break it down. So that's 2 times 22. The 22 is 2 times 11. And just like that, look at that. We're done with our prime factorization. So 2 times 2 times 11. Here we have a matching pair. A 2 comes out, but that 11 stays inside that radical. So here we go. 2 square root of 11 is what I have left. But as we mentioned before, we do have 3 outside values, right? And so if that's the case, I can definitely reduce all of them by 2. So let's see what we get. X is equal to 8 divided by 2. So that's now a 4. Plus or minus 2 divided by 2 is just 1. But I'll only write the radical 11 because we never write invisible ones next to them. All over 2 divided by 2 is just a 1. which normally we would never write. So here's my answer. It should just be 4 plus or minus the square root of 11. And just like that, we have our two solutions. Don't forget, we have two of them because of the plus or minus. All right, so if you need to make any changes or fix anything, please do so. And then let's check your answer for number 8. Here's our A value. Here's our B value. Here's our C value. All right, here we go. It's time for the discriminant. Something squared minus 4 times something something. Our first value is the B, so there's our -5. There's our A, -2. And our C is -6. All right, again, something this full of negatives, throw it into Desmos. But if not, then you would work them out individually. 4 times 2 is 8, times 6 is 48, which of course gives me a -23. And because of that negative, we now know we're going to have two imaginary roots. All right, so that just means one thing. My answer has to have an I in it, right? This is why we do the discriminant. It helps us figure out what my solution, right? What my answer is going to be, or sorry, how many answers I'm going to be, how many answers it will be, and if it's imaginary, then I'll put a letter I with it. Okay, so here we go. X is equal to negative blank plus or minus the square root of all over 2 times blank. Just remember, we already did some of this work. We know we're going to bring this in right inside our square root. Our B value is -5. The square root value, right? Our discriminant was -23. And our A value is -2. All right. So negative times a negative is positive. Plus or minus, the 23 cannot be reduced, right? Even if I try the tree method, the 23 doesn't work. But that negative inside, we know there's going to be an I in our problem. That's what the discriminant told us. And since I can't reduce a square root of 23, I just leave it alone. The bottom, though, 2 times -2 is -4. So this is the only time you just have to watch out. We should distribute that negative or divide by that negative, right? We do have an imaginary value. So 5 divided by a -4 is -5 over 4. Now, look at what happens with the plus or minus. The positive first. A positive divided by a negative is negative, but then look at the other one. A negative divided by a negative is positive. So if you notice, the plus or minus doesn't really change. It's still going to be there. But now I have the square root of 23 over 4. And of course, as usual, we have our I value to the side. And just like that, there's our two imaginary solutions. All right, so hopefully you're getting a better understanding of these quadratics, even when they start to get a little bit more interesting than the ones we've seen before. Besides that, make sure that you work on your homework, make up any missing work, and then get ready for the next set of notes. Have a good day, everybody.